Hello everyone and welcome to this video. Today we're gonna talk about one of the three additions on Swift 5.2. The one that it's called callable values of user-defined nominal types. As usual, these proposal names are a little bit tricky to parse, but this is basically SE0253 if you want to look for it, and it basically introduces a way to statically call types. Use the callable syntax on any type that the user defines, which is quite powerful. But first, let's take a look at what that means. What do we mean by callable types? Swift before this version had three different ways of have callable types. The first and more obvious one is when you have a function that does something. In the case it doesn't do anything, but you get the gist. And what this means is that the function name you are able to call it using the parentheses. That's the first and most obvious way of having a value that you can call, that you can use the callable syntax. The second kind of value are the types itself. When we have a struct and we use the name of the struct, we can actually use the callable syntax on the name directly. This is just syntax sugar for the init method that the compiler generates on any type that we create. In Swift 5.0, the language introduced what is called a dynamic callable. This was part of the effort to interoperate in a better way with languages like JavaScript or Python, basically dynamic languages. This was a big effort to try to make it easier to use Swift in things like machine learning, where Python is one of the mainly used languages. To have an example of that, we can just make, imagine that we have a JavaScript value because we want to interoperate with a JavaScript runtime. I think this was one of the original examples that they had. So what the proposal introduced was the dynamic callable. We also had dynamic member lookup, which I have a video about it on the channel because it allows you to create properties on the fly, like to do member lookup with anything you want, and the compiler just eats everything you give it. So the idea is similar with dynamic callable. If we try to compile this, the compiler is going to tell you, okay, I need you to implement one of these two functions. Let's just add a simple implementation of this. So now the compiler is happy with it. But basically what dynamic callable did back then was that you could have a JavaScript value, and now you can call directly this JavaScript value. And you can pass, as we define here, strings, you can pass a string here. And you can run this, and the compiler is perfectly fine. It doesn't complain at all. The disadvantage of this is, like, even if there is a little type safety, because you cannot pass here, for example, a number, then the compiler doesn't know how to rewrite this into this function. But you can pass kind of anything you want here, like especially if you do it properly, you usually are going to use a JavaScript value here, which means that you can do kind of anything you want. So the compiler helps a little bit to keep the type safety that we are used to Swift, but it doesn't go the whole way, obviously, and that's what we want because that's where we have a dynamic callable system. But more often than not, that's not what we want if we're trying to use a similar system for native Swift types. And that's what this new proposal introduces. So now that we understand the different types of callable values that Swift supports up to Swift 5 when this was introduced. Now let's take a look at the new proposal SE0253, which introduces static callable types defined by the users. And this is implemented on Swift 5.2, which is what we're trying here with Xcode 11.4. And let's, for example, introduce a simple example that it's going to be an adder. So you give it the base integer you want to add all the time, and then in a similar vein as what we did with the dynamic callable, we have this magic function that you need to know about it. Like there is not even a notation here, it's not a protocol, it's nothing. You just need to implement this function here, and this function can take the form that you want. You can return things, you can add parameters, labels, anything you want. It's like a normal function in Swift. The only requirement is that the name needs to be exactly callAsFunction. And once you are here, then you can just implement wherever you wanted to implement. And from this perspective, nothing has changed. The difference is that we can say, for example, let's make an add3, and we can have this other, and we pass like the base is 3. So you can do add3 callAsFunction, and you pass a 10, and that's gonna do the obvious thing. But the nice addition here is that add3 now supports to be called directly, and you can even see it here suggested, which doesn't happen with the dynamic callable stuff, where you can do pass 10 here, and it exactly does the same. So that's what we mean. Now we created a type here. If you look at this is not a function, this is actually a type, it's the other type, but we can call it. This is really powerful and really nice because it's another tool that Swift offers to have nice and elegant APIs. There is many times, and we're going to explore some of them now, where it doesn't make sense to have a name for the main function that the type does. For example, on this case, normally you will have done add, and you're going to basically will have written exactly the same thing, so there is not much difference, but you will have this method here. So what you will do is you will have to add, call the add method. And once you're reading here, like, you can see that the API is not that elegant anymore, because you are creating another, and then what is the other gonna do? It's gonna add. So you're gonna have other, add3, add. It doesn't read as nice. Instead, if you say, I have another, and I can just give it a number, and it's giving me the result. That's pretty much it. It's an elegant way of making an API. So that's pretty much what it introduces, but I think it's important to understand for what we can use these, what examples exist in the wild. I will try to show you some of them. A lot of people has been waiting for this for a while. Other languages have similar functionalities that allow them to have nicer and shorter and succinct APIs. I'm really happy that Swift is able to do this now. The main two use cases that you can use this are like mathematical types and functions, like you can see here, and the other way are, as we mentioned, like they are types that they have a mainly one functionality that you want to use all the time. And often in that scenario, the name of the type kind of resembles the action that you're doing. You don't want to be repeating the same word or similar word all the time, so this is really nice for these use cases. Let's take a look at one of these mathematical examples. We have here a polynomial struct. The way you use this, which is the coefficients that you want this polynomial to be. And now you can just call polynomial evaluate, and let's give it a 2. So that's gonna meet the mathematical function, it's gonna give us the return. Yeah, and that's fine, and that's a nice API. But what if we imitate the same API, but with the callAsFunction? We don't even have to repeat it, we can just literally call the existing function, so people can use any of the two if they want. Like, we can support both APIs at the same time. And now this polynomial that we already have, you just need to pass it. You have a nice API, you know it's a polynomial, so because it's an understandable concept that we know from math, you know that a polynomial, you give it a number to substitute for the x, and it gives you a result. You don't have to have a specific method for it, because there's nothing else that it's gonna do. So now, instead of talking only about math, let's talk about some kind of more approachable examples in applications. Like, imagine that we have some drawing system. Let's imagine that we have a shape, a renderer protocol, and this renderer is gonna have a render that you give it a shape, and it does something, it renders something. This can be like, I don't know, 3D renderers, 2D renderers to the screen, it can print into paper, whatever you want. We can add support for statically calling types, not only to structs, but also for classes and even for protocols. We can extend the renderer type directly and add support for the statically callable, and now any type that we have, like for example a 3D renderer, for free, we can actually call the renderer, as you can see here, with a shape. And this works out of the box, so which means that every renderer that the consumer of Yugo API will implement, they have this functionality for free. You can just pass a shape into the type itself. Try another thing. Let's try to create a splitter type. Okay, this, think about it like kind of as a parser, but because a parser is another good example of this. Like a parser, what is gonna do? A parse. You can use directly. You give it the string, and it will do it the same. But let's, for example, to change a little bit, let's implement a splitter where you give it a character, and it's gonna split strings based on that character. What this allows us is that instead of, let's take a look at, this would be what you will do originally. You have a splitter, that is going to split strings based on spaces. And you have a splitter that you split the text. You can see it doesn't read that nice. And I don't know you, but I've written types like this. And I always had this situation where I wanted the language to allow me to just avoid this because I know what's already doing. And you can do workarounds, the function directly, and that works, but it's not as elegant. And it's really nice that the Swift supports it now out of the box. What this allows us in this case is to start making kind of like a small DSL, a small language specific, which you can have a space splitter and you can build the library of these splitters. And it's going to be exactly the same. You do this, so you split based on spaces. What's the difference? That now you have a space splitter and you know what it does, just for the name. So you can build a library of this, the same thing, but with a nicer API. And we can go the extra mile and remove this label here because it doesn't add much because we already have the context. And as you can see, this keeps working and the API is much nicer. So as I can say, this is a huge improvement if you want to start building APIs like this. One of the things I've been doing for a while as a pet project that I have is I have a role-playing calculator, so you can just put any typical calculation with dice and constants and additions and probabilities, and it will do the calculation for you. Let's build a simple scenario. You can imagine that the roll string, it's something like roll 2 d20s and add my 5 modifier from my strength. And that's how the current API like of many of these things works, like not only mine, like I've seen some online and they all do the same thing. And it's not that nice. So you can see again, we're just doing the same thing over and over. You just need to implement this function. This is an improvement and I'm starting to change my APIs on this side project for this because it's a much nicer way of working. I'm talking about role-playing games. Like let's say that you have a roll which will simulate like a dice. And let's say we have a minimum number for that imaginary dice. The score is gonna be, let's put it default for 1. So we make the initialization easier, and then you can have the callAsFunction, and here we just do the calculation. We can even avoid making a named function. Like we can just, like before we did here, we did the calculate and then we reuse it here. You don't even have to do that. You can just do it directly on the callAsFunction method, and that's it. And that's the nice thing now, that you can do a d20 and you can say, okay, roll for 20, and now you can do roll for me d20 directly. And you don't have to call a method name or anything because you already know a d20 what it's going to do. It's going to roll a d20. There's nothing much to do there. So it's really nice. One thing I like is that this functionality supports syntax overloading. So you can even implement here, we can just accept a count for the number of dice that we want to roll, and we just do the addition. And now we have the ability to roll a d20 5 times, and that's gonna roll 5 d20s and add them for us. And as you can see, the API, it's really nice and it's super powerful that you can overload this, and it's all statically checked. It's not like the other functionality that it's all dynamic. And now let's take a look at another type that you probably use in your applications, which is just a cache. In this case, let's just use a simple version. It's like just a dictionary. You could imagine how this cache was a disk cache or even in a key store database. Whatever you use, the important thing is the API and the type itself. So the way you will use this is like, of course, like you initialize this cache with the generic parameters. So let's just store strings, and here, yeah, you have a cache and you're gonna cache. Is this nice? Not really, let's be honest. But let's see how it looks if we implement the callAsFunction. And again, we give it the value for key. Now compare this, because you can just cache for the key, and that's it. It simplifies a lot the calling side. So it's really nice. In this case, maybe that's not the best solution, because probably I think it's nicer to use a subscript here, but you have the option now. And now let's try something more esoteric. You know, in Swift we have closures, and closures can capture values. But sometimes we want this to have a little control over it. So we want, for example, to be able to capture only one value, one specific value, and have that value be constrained for something. This is commonly used, like there are some APIs and some libraries that allow you to pass a class, and they capture that class weakly, and then you can use that directly on your closure without capturing it yourself. So you ensure that you don't have to do the weak, strong, dense, and all that stuff. So the proposal itself has this type, which is a bound closure. And this type basically has two things, like the function itself that you want to run, where the input parameter is of the type that we want. As you expect, we can just do the implementation of callAsFunction. The proposal, for example, talks about that this is more performant than using a closure directly, because it does the abstraction is a little more efficient for the optimization of the compiler. Not sure about that, I'm just repeating what the proposal said. But now imagine that you have a value that you want to capture, and you have this closure. So instead of making a normal Swift closure, you can make this bound closure where you print, but instead of capturing X, you pass X into this bound closure. The nice thing, like you could do this before, but you were not able to treat a closure as a real function that you can call. You will have to, for example, do that call here, which is something that many people did. It's not that nice, now we have this, and literally there is no difference between this closure two, as you can see. One, it's a real closure, the other, it's this type that we created, and the syntax is exactly the same. That's really powerful. There is one thing that sometimes is really useful, and it's not easy to do in Swift, and it's compare functions. In some systems that you build, you want to be able to have functions or closures be equatable, for example, and that's not really that easy in Swift. But what you can do is you can create a function type with an input and an output, and you can make this type equatable. Just for simplicity, we're just gonna make it equatable based on the ID, and the ID is gonna just be a string that the user provides. So probably not the best way of doing, but it illustrates the purpose of it. And then of course, like this function needs some code to run, so we're gonna make a real closure that we inject at init time. This type now can be used in any functional way, like that you're used to use when you use functions, which Swift has functions as first class citizen, which you can pass around and store in variables and all that stuff. You can do exactly the same thing with this, and the advantage is that you have the nice syntax and that it's comparable. Just let's take a quick look at how this looks. For example, we can have a function that accepts a string and returns an int, and as I said, we pass an identifier. What you can do now is you can have this equals words, and now you have two functions, and you can compare if they are equal. This is quite powerful if you have these functions like this, but if you pass these functions into objects and you store them there, and you want to implement equality on those objects, now with this type you can do it, and you can even use the compiler generated equality for free, which is super nice. And the usage of this, it's no different than if you had a function itself, because you can just call it, you can pass the parameters directly, you don't have to use another function as an intermediary. It's really nice. What this allows you to do is to incorporate some functional ideas into this type, which is like an object oriented type, but now you can have, for example, a then function that allows you to chain these functions, and you can introduce all these functional ideas without operators, for example, or any weird syntax. For example, let's introduce a new function that basically it generates a bunch of random letters. You can combine the length function with this one, and then you get a new one that goes from string to string. So it's basically gonna count the characters of the given string, and based on that number, it's going to generate a new string with the number of characters. And now you have a new function doing that. It allows us to see how having a type that we can extend, we can confirm protocols for functions, is something really powerful that the language doesn't let us do now, but we can work around it thanks to this new syntax. And basically at the usage side, there is no difference. Everything is still a function. And it's not only nice when you have it here as a free floating functions. You could have a type, for example, that had this function as a property of it, and you could literally use it with that syntax in and everything, and it just looks like if the type had a closure or even a method defined on it. So you can see there is no difference between these, and if you had this as a function or if you even had it as a closure. All this, it's basically the same. So that's it. This has been my exploration of this new proposal that introduces statically callable values to Swift. I hope you learned something, and if you enjoyed the video, please like, and for more content like this, please subscribe to the channel. Thank you for watching, and see you next time.